The ERP Analysis Module is an add-on to LabScribe Software that is designed for studying event-related potentials, or ERPs. An ERP occurs in response to a specific stimulus, sensory, cognitive, or motor, and represents the time-locked average of EEG activity collected over many repeated trials. By averaging multiple responses to the same event, the module reduces the inherent noise present in EEG signals, allowing the stimulus-related potential to be clearly visualized and analyzed. Here is a sample EEG file from a previous recording. In this P300, or oddball test, electrodes on the head captured EEG activity while the subject listened to a sequence of audio tones. Using macros, a 600 Hz tone was played repeatedly in random order, with a 900 Hz oddball tone inserted at unpredictable intervals. A mark was placed in the recording at the moment each tone was delivered. The top channel displays the EEG signal, and the bottom channel displays the audio output. To open the module, select Advanced, Event-Related Potentials, and then ERP Calculations. Select the ERP channel from the recording. Select the reference channel. If there is no reference channel, select None. Next, select the stimulus channel. If there is no stimulus channel, select None. Here, I will select the audio channel from the recording. Click on the Stimulus tab and set the number of stimuli. This can be entered manually or adjusted with the up and down arrows. In this example, I'll select 2 stimuli. For each stimulus, choose whether the software should identify it by its mark or by the start of the block. In this recording, the marks for Stimulus 1 and Stimulus 2 are labeled 600 and 900 respectively. Additionally, there is an option to have the software ignore segments of the data if a mark begins with a user-defined prefix. Next, select the Settings tab. All times set in this tab are with respect to the onset of the stimulus. Set the pre-stimulus period and post-stimulus period in milliseconds. Then, choose the number of cursors you want to use for measurements. The cursor measurements will appear in the data table. Next, configure the measurement parameters. The first option is the baseline setting, with choices of 0, pre-stimulus mean, or mean. Because EEG recordings rarely have a stable baseline, using the pre-stimulus mean is the best option. This calculates the average value over the defined pre-stimulus period and uses that as the baseline. Finally, set the measurement range, which determines the x-axis span in the graph display. For this example, we are interested in the P300 response, which occurs around 300 milliseconds. To ensure the full response is visible, the display range is set from 0 to 1000 milliseconds. The Segment Valid option at the bottom allows you to easily exclude noisy responses or motion artifacts. You can set an amplitude threshold so that any response exceeding that value is automatically excluded. This setting is easier to fine-tune once you can visually inspect the responses. Click the Calculate button to run the analysis. Now we can view the overlaid responses in the graph. Each individual segment appears in gray, while the average of all segments is shown in red. You can switch between viewing the graph for Stimulus 1, the graph for Stimulus 2, the oddball, the combined average of both stimuli, or the difference between them. You can also view the individual segments for each category. Clicking on a segment highlights it in black. Use the up and down arrow keys to cycle through segments, or double-click a segment directly on the graph to select it. We can see that some large artifacts are present in this recording. To handle this, we can use the Exclude Segments option in the settings to streamline the analysis. Instead of manually finding each artifact, I will lower the amplitude threshold to automatically exclude cycles with a range greater than 0.1. Anytime you adjust a parameter, click Recalculate. Additional cycles that you consider artifacts can be manually unchecked to exclude them from the analysis. Double-click on the cycle or cycles you wish to exclude and uncheck the blue box next to that cycle. This can be done for each stimulus. To view the averaged graph for cursor measurements, select Average, then double-click the Y-axis to autoscale. You can click and drag the Y-axis to adjust it manually, or right-click to set a specific scale. The down arrow icon in the bottom left corner allows you to copy or export the averaged data, adjust the X and Y axis, or autoscale. In this example, the Stimulus 1 average shows a flatter response, while Stimulus 2 shows a more pronounced deflection. You can now drag the cursor to make measurements. Expand the data table to view the values. Placing the cursor at the 300 millisecond mark will display that time point and the amplitude difference at that location. The data table can be copied or exported as a CSV or text file. The Algorithms button lists each calculation available in the data table and the definitions for how the software calculates each one. By clicking Table Options, you have the option to select which values to display in the data table. You can also load or save settings templates, although you don't need to do this every time. Just make sure to save the file after analysis, and the settings will appear exactly as they were when the file was saved the next time you open it.